So you've got your sensors, and you know that they're going to be sending information back and forth to your hub, but how does that information actually get there? Well, it does so with something we call a communication protocol. This is a specified way that data is going to be sent between the two devices. That data is sent across something we call a data bus. This data bus is a communication system that specifically calls out which protocol or how to send the information back and forth and how to physically connect the devices. It's going to require specific pins that are already pre-programmed on your device. So when you're deciding how to hook things up, pay close attention to your pin diagrams. There's two categories of data buses. There's parallel data buses, where you have a series of pins that are all sending information simultaneously or parallelly. So maybe you would have 8 pins and each is sending a bit of information all at the same time. Then you have serial data protocols. That's where you're using one pin to send bits of information one right after the other. It requires far fewer pins, and actually they can be really fast. And since in embedded systems, size is almost always the limiting factor, you'll find that we typically choose serial data buses so that we can limit the number of pins and keep all of our devices as small as possible. Serial communication protocols have a few different features. Data is generally composed into either read or write operation. Either I'm taking in a piece of information or I'm giving it out to somebody else. The hubs, like your Raspberry Pi, are officially referred to as master devices, and the peripherals or sensors or whatever you have attached to that device are called the slave devices. The protocols we're talking about here are going to be synchronous. That means that they're paying close attention to the digital clock signal. So the way that the communication protocol works is based on a certain rhythm. Information is going to be given out, then you're going to wait for information to come back, and there's certain time limits that you're willing to wait for both of those operations. This makes it really easy to catch when something goes wrong, because you're not just going to wait forever and ever. You have a certain threshold that you'll wait until you recheck or resend. There's 2 communication protocols you're probably going to most commonly use. First is I2C. The way I2C works is that all the slave devices get specific addresses. So one master device can send information to however many slave devices. This also lets you use multiple devices on the same data lines. So it actually only requires 2 pins, which is incredibly small. It needs one for the clock signal and then one for the data line. And then it figures out who it's sending that information to and what, and figures it all out on a single data line. Then you have SPI. SPI forms a direct pair between slave and master, and then you have 2 different data lines, one for each direction of information. Because you have 2 lines each for the same direction, you can send out and in at the same time. This is called full duplex communication. As you can imagine, is twice as fast as what I2C is doing using a single line for back and forth. But you need more lines. You need 4 lines for this. You need a serial clock line, like you did before. Then you need a master out, slave in, meaning going from your Raspberry Pi to your peripheral. And then you need a master in, slave out, meaning from your peripheral to your Raspberry Pi. And then you need one for chip select so that it can decide who is controlling at what time. We're going to help you decide which protocols to pick. And in fact, a lot of the things that come in your Azure IoT box from Adafruit actually support both I2C or SPI. So sometimes it's totally just up to you based on whether you want speed or to limit the number of pins you're using. You'll find that you'll probably use both of these protocols plenty based on the given situation. But for this course, we're always going to help you figure it out.